everyone. Today, we're going under the hood, well, under the floor, of an electric vehicle. We're going to tear it down piece by piece to really get a look at the incredible engineering that's changing everything. So let's get into it. So let's just start with a super common idea. You take a normal car, you rip out the gas engine, you drop in a big battery and an electric motor, and boom, you're done. Pretty simple, right? I mean, it seems to make sense, but is that really what's going on?
Yeah, no, not even close. What we're actually witnessing is a total ground-up rethinking of what a car even is. The switch to electric isn't just swapping out the engine. It's a fundamental revolution in design, in engineering, and in manufacturing.
To really understand why, you have to look past the battery itself. You have to see the entire vehicle as one complete integrated system. An EV isn't just a bucket of parts. It's basically a high-tech, high-voltage network on wheels. Everything, the battery management, the power inverter, the motor controller, it's all tied together and driven by incredibly sophisticated software. It's a true ecosystem. So let's start our teardown and take a look at the key pieces of that ecosystem. The electric powertrain that completely replaces the old internal combustion engine. First up, the most famous part of all, the traction battery pack. This is the energy source, the fuel tank of the EV. It stores all that high-voltage electricity you need to actually get down the road.
Next, we've got the electric traction motor. This is the muscle. This is what does the real work, taking that electrical energy from the battery and turning it into the rotational force that spins the wheels. And what's super cool is that in a lot of EVs, these are actually motor generators, which means the same part that drives the car can also help recharge it.
But, okay, how does all that power get from the battery to the motor in a controlled way? Well, that's the job of the power electronics controller. This is the brain of the whole powertrain, meticulously managing the flow of electricity to give you that instant torque and silky smooth acceleration that EVs are known for. And finally, we have two unsung heroes. The onboard charger, which does exactly what it sounds like. It takes the AC power from your wall outlet and converts it to DC to fill up the main battery. And right alongside it is the DC to DC converter, which takes that super high voltage from the battery pack and steps it way down to power everything else. Your radio, your headlights, your dashboard. But you know, building a great EV isn't just about assembling these parts. It's about solving some massive engineering challenges, which has led to some truly genius solutions. Let's just take the motor, for example. For a long time, the induction motor was the standard. It's a proven workhorse. But for today's EVs, where every single mile of range matters, the permanent magnet motor is the undisputed champion. Thanks to huge advances in materials, it's way more powerful and a whole lot more energy efficient. Now for another brilliant efficiency trick. In a gas car, when you brake, all that energy is just wasted as heat. It's gone forever. But in an EV, all that forward momentum is an opportunity. This quote puts it perfectly. The energy that it takes to spin the motor is the very same thing that slows you down. Here's how it works. The second you lift your foot off the accelerator, the car's momentum keeps the wheels turning. That forces the electric motor to spin, but now it acts in reverse, like a little generator. It actually creates electricity and sends it right back to the battery. You are literally recharging your car just by slowing down. And the benefits here are just fantastic. You're getting back energy, which means more range and better efficiency overall. Plus, and this is a big one, since the motor is doing a lot of the braking, your actual brake pads last way, way longer. But all of this high voltage power moving around creates one massive problem: heat. Heat is the arch nemesis of batteries and power electronics. It just kills performance, it shortens their lifespan, and it has to be managed really, really carefully. The solution? A ridiculously sophisticated thermal management system. Engineers have come up with these incredibly complex solutions, like Tesla's famous OctoValve. It's basically a central hub that pumps fluid all over the vehicle to either warm the battery on a freezing day or cool the electronics when you're driving hard, keeping every single component at its perfect operating temperature. Okay, so we've taken the car apart, but to really understand its full impact, we have to zoom out, way out. We need to look at its entire life, from the moment it's built to the day it's recycled. When it's actually on the road, the benefit is crystal clear. Electric vehicles have zero tailpipe emissions. Full stop. But that isn't the whole story, is it? I mean, that electricity has to be generated somewhere, and building the car, especially the battery, has its own environmental cost. So what's the real price? To figure that out, researchers use something called a life cycle assessment, or an LCA. This diagram shows you the whole process, from digging raw materials out of the ground, to manufacturing, to the years you spend driving it, and finally, to recycling at the very end. This is how we get the true measure of its impact.
And this brings us to what might be the most critical part of that whole cycle, recycling. Because this number is a game changer. Studies have shown that if you manufacture a new battery using recycled materials, you can slash its carbon footprint by over half compared to using brand new materials. That is huge.
And this idea isn't just about being a little less wasteful. It's pointing us toward the next great frontier in manufacturing, building a true circular economy.
What this means is moving away from the old cradle-to-grave model, where we make something, use it, and then throw it away, to a cradle-to-cradle approach. The ultimate goal is a closed loop, where the materials from old, retired batteries become the raw ingredients for brand new ones, massively cutting down our need to mine for new stuff. Which really leaves us with one final big question. We see the change happening on our streets every single day. But as this transition picks up speed, is it possible that the biggest, most profound revolution isn't the one happening on our roads at all, but the invisible one happening inside our factories?